Hello everyone, welcome to today's class. This is Teacher Simon taking you through IGCSE Extended Mathematics 0580 paper 21 May June 2025, and this is part 2. Question 13 is coming from 3D diagrams. We can see that this is a hemisphere, then there is a cone on top, and then a cylinder. So they are saying that the diagram shows solid A and solid B. Solid A is made from a hemisphere and a cone, each with a radius 6 centimeters. The cone has the sloping edge 10 centimeters. This is the one here. Solid B is a cylinder with radius 4 centimeters and height h centimeters. The total surface area of solid A is equal to the total surface area of solid B, and they want us to calculate for the value of h. Okay. They said total surface area of solid A is equal to the total surface area of solid B. Remember, at first on page 2 they give you the list of formulae. Okay, so you just need to check there, and then you just put the formulae that are needed. Now here for solid A, we have what we call the total surface area. So there is this curved surface area of this hemisphere. When I come to page 2, the list of formulae, they give us the surface area of the sphere. A sphere, just look at a ball. Okay, so it is given as 4 pi r squared. So meaning the one for the hemisphere, it is going to be a half that curved surface. Remember now, when you cut it into 2, it is having this one here. So there is also this one, which is a circle. So that means the total surface area of a hemisphere, it is actually going to be this upper part, which is the pi r squared, then plus a half of this one, which will be 2 pi r squared. So I will have a half of 4 pi r squared, then plus the one for the cone. The curved surface area of the cone is given as pi r l. It is here in the list of formulae. It is here, pi r l, and that l is the slanting edge. Okay, so plus pi r l. Then here, total surface area of the cylinder, we shall have this curved surface. Now, you get a paper, okay? Papers are always rectangular, okay? Like in your book, and then you try to fold it. It is like this. Then try to make this end come to this one, and also this one to this one here. You'll form something like this, okay? So meaning, when I get this cylinder, and I cut it here, it is going to open up. When it opens up, it is going to give us a net that is like this. Okay, this one is the H here, and then this circumference of this circle, which was here, now spreads into the length here of this rectangle. And circumference of a circle is given by 2 pi r. So I'm putting capital capital R, so that it doesn't interfere with the radius of this other side, because they don't have the same radius. Okay. Okay. So that is 2 pi r. And you know that area of a rectangle is length times width. So we shall have 2 pi r and then the h. You see that? Then there is also this circular end here, has an area, and also this one has an area. So usually you find when they draw something like this, they put a circle here and they also put a circle here. Okay, that this is the net of this cylinder here. So now we are going to write here the total surface area is going to be 2 pi r squared, because there are two circles. This is pi r squared plus the pi r squared, so it becomes 2 pi r squared. Then plus the curved surface area of the cylinder is the one that is this rectangle here, which is 2 pi r, then times the h. Okay, now here we have 2 pi r squared plus pi r l, then is equal to 2 pi r squared plus 2 pi r h. Now we substitute accordingly. We have, of course, now I'm going to take out the pi because it is here, 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 and here. So when I divide all through by pi, it goes away. So we shall have 2 times the radius here is 6 squared. Then plus radius is 6 times L here, which is 10. Then this way we have 2 times the radius here is 4 squared. Then plus 2 times the radius is 4. And then times the h. So here this is 36 times 2, that is 72. Then plus 60, that will be 132. Then this way we have 4 squared is 16 times 2, that is 32. Then plus 8h. So that simply means that we shall have 132 minus 32 is equal to 8h. And then 8h will be equivalent to 100. Then h will be equal to 100 divided by 8. Okay? And then from there, by 4, we shall get the 25. Then by 4 also down, we shall get 2. Then this one is actually the same as 12.5. You can write 12.5 or 25 over 2. Then part B, work out the height of solid A. Height of solid A. I'll come to this one here, and then I connect this one here. So this one is going to be a right angled what? Triangle. So we need h here. So since this one is a right angled triangle, then we shall use Pythagoras theorem. Okay, so by pulling this one out, we shall get the h here. Then this is 6 and this is 10. So we say using Pythagoras theorem, okay, we have h squared plus 6 squared is equal to 10 squared. So meaning h will be equal to the square root of 10 squared, that's 100, minus 6 squared, that is 36. And that will be the square root of 64. Because 100 minus 36, you get 64. And then root of 64, that one is what? 8. Question 14 is coming from functions. F of x is equal to 3x minus 4. G of x is equal to 4x plus 1. And then part A, f of minus 2. That means we go to where x is, and then we replace it with a negative 2. So meaning we shall have 3 times a negative 2, then minus 4. 3 times negative 2, that one will give us negative 6. Then minus 4, we shall get negative 10. Okay. Then the inverse. If the inverse here is y, that means when I take the f this other side, it will be x, which is equal to f of what? Y. Now you go here, wherever there is x, you substitute what? A y. So meaning we shall have x is equal to 3y minus 4. That's what you say as interchanging x and y. Now the next thing is to make y the subject. So bring this one this side. It will be x plus 4, which is equal to 3y. So meaning y will be equal to x plus 4. Then you divide by 3. Remember, when we are making a letter subject of the formula, or when we are solving equations, we just undo operations, where plus is undone by the minus is undone by the plus. That's why you are seeing this one as a plus. And then the multiplication is undone by the division. Okay, so inverse is going to be x plus 4, then divide by 3. And then part C, f g of x, this is a composite function, is equal to ax Then find the values of A and the ones of B. So f g of x, this one simply implies that put g of x into f. Now, just like we have f of x is equal to that. Now, in the place of x, okay, we are going to put this whole function g, okay? So that means we are going to have 3, then g of x, and then there is a minus 4, okay? Now, put the function g, which is 4x plus 1 minus 4. Then you have 3 times 4, that is 12x, then plus 3, then minus 4. And this one automatically will give us 12x minus 1, because 3 minus 4 is a negative 1. So meaning A, that is the coefficient of x, is the 12, and then B here is this minus 1. Don't be confused that now here they said plus, but here I'm getting a minus. No, B can be a plus or a minus, okay? So therefore A is equal to 12 and B is equal to negative 1, as simple as that. Then part D, they are saying that we simplify, okay? We simplify 2 out of f of x, then minus 5 out of g of x. We give our answer as a simple fraction in terms of x. So we shall have 2 over f of x minus 5 out of g of x. The first mark is to substitute. So 2 over f of x, remember, we got it as, we have it as 3x minus 4. And then the one of g, we are having 4x plus 1. Now, these are what we call algebraic fractions, okay? So when we are getting the LCM, or the common denominator, just get these two, you multiply them. You don't need to waste time. Then get this one, multiply with this, get this one, multiply with that. We call it the butterfly method. So we shall have 2, then times 4x plus 1, okay? Then there is minus, this 5 here shall multiply with the 3x minus 4, and then we shall divide by this 3x minus 4, then times the 4x plus 1. You don't need to waste time to open brackets here in the denominator. Just simplify what is up here in the numerator. So we open the brackets. This one is going to be 8x, then plus 2, then minus 15x, and then here negative times a negative, you get a positive, right? So we shall have positive 20. Then out of 3x minus 4, and then 4x plus 1. So meaning 8x minus 15x, that one will give us a negative 7x. And then 2 plus 20, that one will give us 22. Then out of the 3x minus 4 multiplied by 4x plus 1. So this one is going to be my answer. It is what I just shift from here, and then I put it here. As simple as that. You can even write 22 first, because in algebra, you can write the positives first, then the negatives last. So we can write 22, then minus 7x, then divide by this one. It is still the same thing. Question 15, part A, expand and simplify. This one is actually coming from Surds. Remember, whatever is in the first bracket is supposed to multiply with whatever is in the second bracket. So meaning 2 will have to multiply with 1 minus 3 root of 5. And then remember, this sign here goes with this, like I told you before. So we shall have minus root of 5, also multiplying with 1 minus 3 root of 5. Then we open the bracket, so 2 here, then minus this 2, it doesn't have a root on it, so it just multiplies with this number here, the coefficient of this side. So we shall have 2 times 3, that will be 6, then root 5. Then minus root of 5 times 1, that is root of 5. That is root of 5. And then we shall have, first of all, a plus. Then, of course, let's say we have negative 1 here times the negative 3. You are getting positive what? 3. Okay? So plus 3, then now root of 5 times root of what? 5. Now it's like saying root of 5 what? Squared. And you know that square root of 5 is the same as power half. So it's the same as 5 power half. Then there is this. And using the rules of indices, then we shall have 5. This a half multiplying with the 2, and then it goes. So that's why in Surds we shall have something like this. We have a rule that root of a times root of a is always equal to a. Okay? So what are we therefore going to have? This is 2 minus minus 6 minus 1, because surds are said to be added or subtracted if the number under the square root sign is the same. So you have this and you have this, which is the same. Okay? So minus 6 minus 1, that will be a minus 7 root of 5. Then you come to this one here, it will be 3 times 5, which is a 15. So plus 15 here. Now 2 plus 15, that will be 17. Then minus 5 root of 5. I mean minus 7 root of 5. So that will be our answer there. And then part B, rationalize the denominator. To rationalize the denominator, we multiply. Let me write it here. We multiply the denominator and numerator by the conjugate of the denominator. By the conjugate of the denominator. Now, if a surd is, let's say, a plus, let's say, root of b, okay, then its conjugate, the conjugate, okay, is going to be a, then minus root of b. So you change the sign here. So, but now, for this one here, you are not going to change the sign here because we don't have any other term in here. So we rationalize the denominator. Rational, it means to make it a fraction. That means we must have a real value in the denominator. So we just multiply the numerator by root of 10 and also the denominator by that root of 10, because we have seen that root of a times root of a, you get what? You get a. So meaning that when I multiply here, root times a root, it is going to go away. So here I'll have 6 root of 10, then we divide by, here I'll get 10. Now I can simplify it by 2, we shall get 3. Then by 2, we shall get 5. So our answer is going to be 3 root of 10 over 5. Then question 16, expand and simplify these 3 brackets. You can begin by expanding those first 2, then the result, you multiply it in this one. Or you can begin with this one, so whatever you want. You can even begin with this and this one, then times this. But why would you do that? You jump. So I'm going to begin with this x plus 4, then times x minus 3. This one is going to, remember what is in the first bracket must multiply with whatever is in the second bracket. So x here has to multiply with x minus 3, and also 4 will multiply with x minus 3. You see that? So meaning we shall get x squared minus 3x, then plus 4x, then minus 12. And then simplified, this one will be x squared, then plus x, and then minus 12. Because this is positive 4 minus 3, so you get a positive 1, right? Okay, then from there, we shall have x plus 4 into x minus 3 into 3x plus 2. Now this one is going to be x squared plus x minus 12. Then we multiply by 3x, then plus 2. Whatever is in the first bracket must multiply with whatever is in the second bracket. So I'll have here x, again multiplying 3x plus 2, and then minus 12, also multiplying with the 3x plus 2. Okay, then 3x times 3 times x squared, that will be 3x cubed, then plus this will be 2x squared, then here 3x squared, then plus 2x, and then minus this will be 36 of x, then minus the 24. All of this simplified, we shall have 3x cubed, and then this will be what? 5x squared. So plus 5x squared, and then 2 minus 36, that one will give us minus 34. So minus 34 of x, then minus 24. As simple as that. Question 17 is coming from probability. They are saying part A, a bag contains 6 red marbles, 3 green marbles, and 1 blue marble. 2 marbles are picked at random from the bag with replacement. So if you pick with replacement, that means the probabilities are going to be constant. Because if you have picked the red, first of all, before you pick, the probability of picking red is going to be 6 out of the 10, because the total is going to be 6 plus the 3 plus the 1. Okay. Now, when you put back, that means the next time of your picking, still you are picking from the lot that hasn't changed. But without replacement, the totals keep on reducing. So they are saying, find a probability that both marbles are green. Now, if both marbles are green, so we shall say probability of green intersection green, that one is going to be, first of all, the probability of picking green is 3, then out of 10, then times. Now, when you put back, still greens are 3, and the total is 10. So you have 9 over 100, which you can write as 0.09. Okay. Then part B, another bag contains 4 red counters and 2 yellow counters. 2 counters are picked at random from this bag without replacement. Complete the tree diagram. Remember, here the totals are going to be reducing. So let's say here they are picking the first counter. Every time you are picking, you are either picking red or yellow, because those are the ones that we have in the bag. Okay. Now, how many red counters do we have? 4. Out of the total 4 plus 2, that will be a 6. So that's why you are seeing here 4 out of 6. And then this one is 2 out of 6. And remember, for the 2 branches here, when you add up these probabilities, you must be in position to get 1. If branches are 3, the same thing. When you add up, they should give you 1. Now here, you have picked 1 red. You have not replaced it because it is picking without replacement, and you put it outside. That means you are now remaining with 3 out of these 4. So the next time you are picking, the probability of picking a red from there is going to be 3 out of the total, which is now 5. Because remember, the total was 6. You picked 1 and threw it outside. Now the total has reduced to 5. So that's why you are seeing 3 out of 5. So you just say 1 minus the 3 out of 5, then you get 2 out of 5. Or it's the same thing as saying, since you picked red, yellows are still 2, though the total reduced. So it is 2 out of the 5. See that? Okay, then here, if you pick yellow, okay, the next time you pick yellow, the probability of picking yellow is going to be 1, then out of the 5. Then this one has to be 4 out of what? 5, because when you add these two, you get what? 1. As simple as that. Now they are saying Roman 2, find the probability that one of the two counters is yellow. So probability that one of the counters is yellow. That means the first counter, okay, can be red. Then the next one is yellow. You see this? Red, yellow. Then we can also have yellow first and then red. One of the two counters is yellow, 1, not 2 of them. So we shall have yellow and then red. Now, the other one is 4 over 6 times probability of picking yellow, that is 2 over 5. Then this is 2 over 6. Then times red, this one here, 4 over 5. And this one will give us 8 out of 15. No, 30. Then also 8 out of 30, which will give us 16 out of 30. Okay, so we can write our answer as 16 out of 30, but then 16 divided by 2 can give you 8, then 30 divided by 2 can give you 15. So the answer is 8 out of 15 simplified. Question 18 is coming from speed, distance and time. One day, Anya runs 12 kilometers at a speed of x kilometers per hour. The next day, she walks 10 kilometers at a speed of x minus 4 kilometers per hour. But write down an expression in terms of x for the time she spends running. Now, we know that using this triangle here, this is speed times time, will give us distance. So here, whichever I want, I just cover it. For example, here we need time. So if I cover this one here, that means I will get distance over speed. Okay, so time is equal to distance over speed. And what is our distance here? They said she spends running. This is the one here. The distance is 12 kilometers. The speed is x. That means our answer is going to be 12 over x. Then they said write an expression in terms of x for the time she spends walking. The same thing. So we shall have 10, that is the distance here, then divide by the speed, x minus 4. So all of it is in hours. Then part C, the time Anya spends walking is 1 hour more than the time she spends running. Write an equation in terms of x and show it simplifies to this. Okay, now I'm going to say my T1 is equal to, let's say 12 out of x. Then my T2 is equal to 10 out of x minus 4. Okay, they say that the time she spends walking, this one here, is 1 hour more than she spends running. So meaning we shall have T2 is equal to T1. Remember, it is in hours, so plus 1 hour. Okay, that means we are going to have our T2, which is 10 out of x minus 4, then is equal to T1, which is 12 out of x, then plus 1. Now this one is the same as 1 over 1. And then I need to have one fraction. So this will be 12. Of course, this one here is going to give us, the LCM is going to be 6. Now, I mean x, then you also multiply this with that, and then this with that. So we shall have 12 plus x, okay? Then out of what? X. Then if we can cross multiply, we shall get 10x, which is equal to, now 12 plus x here has to multiply with this x minus 4. Okay, now from here we can have 10x, 12 times x, that is 12x, 12 times negative 4, this is minus 48. Remember, whatever is in the first bracket has to multiply with whatever is in the second bracket. Now we go to x times everything here. So we shall get x squared, then minus 4x. Bringing this one, this other side, we shall have x squared. This is 12x minus 4x. That one will give us 8x. But when this one crosses, it is a negative. So minus 10x. Then minus this 48. Then is equal to 0. Then this one will give us x squared minus 2x. Because 8 minus 10 is negative 2. Then minus 48. then is equal to 0. So that is what you get there. And that is what they have told us to prove. Then next, D, use factorization to solve this equation. Remember, this is a quadratic equation. So we can use factorization, bulldozer, we can use completing squares, but now we are sticking to factorization. So if you use any other method apart from factorization, you are going to be crossed because you are not following what? Instructions. Now, we need to get the sum. Two numbers, when you add them, they give us -2, which is here. But when you multiply them, okay, the product, they give us A times C for a quadratic equation, which is ax squared plus bx plus c, okay? The product is this coefficient of x squared times the constant part, okay? So AC, so we have 1, then times -48, which is -48. Now, two numbers, when I multiply them, they give me 48. 48, we have 12 and 4, we have 6 and 8. I think I will take 6 and 8, but since this one is -2, that means the negative should be on a bigger number. So when you get 6 plus -8, you get -2. So meaning I'll have x squared. Now these numbers, I put them in the place of what? That sum, the 2x. So I would say x squared, then minus 8x, then plus 6x, then minus 48 is equal to 0. These ones were 3 terms, now they have become 4. So I split this one into 2, okay? Then here what is common? X is common. So here we shall have x, then minus 8. And then what is common here? 6 must be common. But you don't need to waste time. You just open another bracket and you put x minus 8. This bracket has to be the same as this one here. Then you ask yourself, what should you multiply with this x to get 6x? Of course, that is positive 6. Now, what is common? X minus 8, and also here. Meaning, I will write x minus 8, and then x plus 6. Then we get this x minus 8, you equate it to 0. Your x will therefore be 8. And then also x plus 6, you also equate it to 0. And then your x is going to be -6. So I'll write here -6 and then +8. Then there's a find the time Anya spends running. That is part E. Of course, since x here is negative and positive, and time cannot be a negative, just like we saw here, the time spent running is 12 over x. So I'll say 12 over the positive value, which is 8. So here the time is going to be 12 out of x. That is 12 divided by 8 by 4. By 4. So we shall get 3, then 2, which is the same as 1.5. Question 19 is coming from Indices. Find the value of 27 power -2 over 3. Now 27 by 3, I can get 9. Then by 3, 3. By 3, 1. So meaning 27 is the same as 3 cubed. So I'll write 3, then cubed. And of course, using rules of indices, if we have a power b power c, this is the same as saying a power b times c. So meaning I will have 3, then the 3 here will multiply with the -2 over 3. So of course this one will go, then we remain with 3 power -2. And using rules of indices, if I have 1 over a power n, this is the same as a power -n. So I can take this one down and it will be 1 over 3 squared, which is actually 1 over 9. And that will be our answer. Then question 20, find the exact value of x. This one is a right angled triangle. So for a right angled triangle, we use 2 principles here. One is the Pythagoras theorem if we are only dealing with the sides. And then we have SOHCAHTOA if we have an angle involved. So we have an angle here involved. And using SOHCAHTOA, S stands for sine, C for cos, and then T for tan. Then O, opposite, H, hypotenuse. Adjacent is for A. Okay, now this means that this one is the side which is far away from the angle is what we call the opposite. Okay, and then the side which is perpendicular to the opposite is what we call the adjacent, and then the longest side is the hypotenuse. Now, having known that, so we have opposite and adjacent. We look at our SOHCAHTOA. This is the TOA. Okay, we shall take this one into account. So meaning that will be tan of 30 degrees, which is equal to the opposite 6 out of the adjacent, this one here. Meaning when we cross multiply, our x here is going to be equal to 6 out of tan of 30 degrees. Now this is 6, tan of 30 is 1 over root of 3. So meaning we shall have 6 over 1, then times. The reciprocal of this one is going to be root of 3 over 1. So the answer is going to be 6 root of 3. They say the exact value. So leave the surd in your answer. Okay. Now, some of you may not know where we are getting the tan of 30 from. In specimen papers, I showed that. Okay. I showed that on this channel. So you can go and pass through. However, this is what we do. Tan of 30. So we use an equilateral triangle. Okay, we use an equilateral triangle. In fact, let me shift everything here to here. Then this part here should go here. Then we have that. So we can have an equilateral triangle. Let me assume this is my equilateral triangle. All sides are equal. And of course, this one is going to be a right angle triangle. So if this one is 60 degrees, right angle triangle, the angle is 60, okay, all through. So this one will then be 30, and then this one, what? 30. Now, if all of these ones are the same, and then I have this one as 1 unit, this one as 1 unit, then this will be a half, and this one will also be what? A half. So I need this h here. Now, since this one is a right angle triangle, then I can use Pythagoras theorem, okay? So using Pythagoras theorem, you can have h squared plus a half squared, then is equal to 1 squared. This squared plus this squared is equal to this squared. Okay. By the way, it doesn't matter whether you use the 1, you can use it 2, maybe this will be 1 and this will be 1. You can also use, what else? You can use maybe x. This is x, this is x, this will be then x over 2, x over 2. That x will disappear when we are finding the values later. So h here is going to be the square root of, this will be 1, then 1 over 2 squared, it will be a quarter. So 1 minus a quarter, you will get 3 quarters. So 3 quarters. Now, meaning we shall get root of 3 over root of 4, that is a 2. So our h is this value here. Now, let us use SOHCAHTOA, because that is a right angled what? Triangle. And we need the value of tan of 30 degrees. Tan of 30, remember tan is opposite over adjacent, right? So the opposite is here, which is a half. The side which is far away from the angle, that will be the opposite. And then the one that is perpendicular to it will be the adjacent, okay? This will be the hypotenuse for this angle 30. But when you come to 60, this side here will be the opposite because it is the one that is far away from the angle. And then this will be the adjacent, then this will be the hypotenuse. So tan of 30 is going to be this half. Then we divide by the adjacent, which is h, which h is actually root 3 over 2. So using the rules of fractions, we shall have 1 over 2, then times the reciprocal of the denominator here, which is going to be 2 over root of 3. Now we see that this one disappears, and then you get 1 over root of 3. So this is the one that I had here, that tan of 30 is 1 over root of 3, okay? And then we get our answer here as 6 root of 3. So whether you want tan of 60, sine of 60, cos of 60, now you can use this triangle. Already we have gotten the h here, but in the specimen papers that are on my channel, I showed all of that. Question 21 is coming from vectors. OABC is a rhombus, all sides are equal, okay? And O is the origin. The diagonals of the rhombus intersect at P. OP is 2m, AP is n. Find in terms of m and n in the simplest form, OA. So from O to A, what do we see? O to A is the same as saying O to P plus P to A. So this will be OP, then plus PA. Then OP is 2m. But AP, this is AP, and the arrow is facing this way. But for us, we are going this way. That means we are moving in the opposite direction. So that will be minus n. So we shall have 2m, then minus n. We usually put these wavy lines because for us, we are not supposed to write these as bold as they are, okay? Because if you do so, then it is going to look untidy if you write that, no. So for us, we put a wavy line. Then OC. So from O to C, I'll say this one is equal to OP, then plus PC. O to P, then plus P to C. And we know that the diagonals of a rhombus, they bisect each other, okay? So meaning this part here is the same as this part here. This one here is the same as this one here. This one is the same as that. So since PC is also going into this direction, then it will be equivalent to n. You see that? So our OP is 2m, and then our PC is also going to be n here. So that means the answer here is going to be 2m, then plus n. As simple as that. Part B, D is a point such that AD is equal to that. Show that OADC is a trapezium. Now, a trapezium has two parallel sides, which we need to find out. So we need to find vectors, and then we see the ones that are connected, because parallel vectors, one vector is a scalar multiple of the other. So from here, AD is equal to actually OD minus OA. How does this one come about? If I have my 2 points, this is A, this is D, and this is O, okay? Then for me to get from A to D, I will say AO, okay? AO, then plus OD. But you can see that this one becomes a negative because we are moving in the opposite direction. Okay, does that make sense? So that's why I'm saying that you just get the last minus the first. So OD is, do we have it? No, it is the one actually we are going to look for. So we have AD, then plus OA. This one should give us the OD. Now, this is 10m minus 3n, then plus OA, which we have as 2m minus n. So meaning our OD here is going to be equal to, this one is equal to OD. So OD is going to be equal to 10 plus 2, that will be 12m, And then minus 3 minus 1, that will be minus 4n. I keep that there. That is OD. Then, if this one is a trapezium, now we have OA. We also have C. Okay? We have C and D. Now, we need to look for the positions where D and C are going to be. Now, I'm going to remove this one here. Okay? Let me remove it and then I draw my other diagram. Let's say our trapezium is like this. Okay? Then I can say O, A, D, C. That means the parallel sides, we have OA and then CD. Already we have AD. Now let's see the connection between AD and OC. Why have I written it like this? Because another person would have said maybe the trapezium is like this: OA, then D, C. So let's look at AD, which is this one, and then OC. So look at OC here and this AD. Are they parallel? When you look at this one here, 2m, this is 10m. That means we can multiply by 5. So if I multiply this one by 5, I'll get 10m, then plus 5n. But this is minus 3n. That means these two are not parallel. So now I have to change. So that's why I've changed to this one here. Maybe it is like this, such that I look at now AD and OC. Okay, AD and OC, are they related? So let's look at, do we have, which one? So I'm looking at CD and then OA. Okay, CD and then OA. So let me take away this one here. Now, OA, we have it. So what is CD? Just like before, just get the last one minus the first one. Our OD is 12m. So minus 4n. Then our OC is 2m, then plus n. That means we shall have 12m minus 4n. When we open the bracket, say this is minus 2m, this is minus n. That means our CD is therefore going to be equal to 10m, then minus 4n minus n, that will be minus 5n. Now, I want you to look at CD, okay, here, which is 10m minus 5n, and you also look at, remember CD is here, then there is OA. So let's look at OA. OA is 2m minus n. OA is 2m minus n. Now, when you look at this one here, you can actually see that CD is actually 5 of OA. Okay? These are scalar multiples, because when you multiply this one by 5, you get this one here, you see? So that means our trapezium are supposed to look like that. So I'll say CD is parallel to OA. Okay? Therefore, OADC is a trapezium. Like that. That is that. Question 22 is coming from differentiation. A curve has this equation here. dy dx is equal to 3x squared minus 12x plus 9. Part A, find the value of n and the value of q. Now for y, which is equal to a x power n, then dy dx is equal to, drop the power and then you reduce it by 1. So you have a n, then x power n minus 1. This is what we are supposed to use here. So meaning, if y is equal to x power n, then plus q of x squared plus 9 of x. Then dy dx is going to be, drop the power, that will be n, then x power n minus 1, then plus, drop this power, we shall have 2q, then x power 2 minus 1, you get 1, and then plus 9. Okay, now if I look at this 3x squared minus 12x, then plus 9, already the 9 is there, minus 12 here, we'll go to that 2q, and then the 3 will be that. So n is equal to 3. We can even say n minus 1 is equal to 2 from here. Okay, this power here is equal to that. You would still take this one this side, and then your n gives you what? A 3. You see that? Then q, we shall have 2q is equal to negative 12. That is the coefficient of x. So meaning q is going to be equal to negative 12 over 2, and that one will give us negative 6. As simple as that. Work out the coordinates of the turning points. We know that for turning points, dy dx is always equal to 0. So for turning points, dy dx is equal to 0. We shall get the 3x squared minus 12x, then plus 9, we equate it to 0. We can divide all through by 3. That one will give us x squared minus 4x plus 3 is equal to 0. Two numbers, when you multiply them, they give you 3, but when you add them, they give you negative 4. That will be negative 1 and negative 3. Okay, so meaning when I equate all of these ones to 0, x will be equal to 1, or x will be equal to 3. Now for x is equal to 1, what is y? Now you substitute in here. Okay, remember y is equal to x power, our n is a 3, then q is a negative 6, so minus 6x squared, then plus 9x. So then we can say for x is equal to 1, then y is equal to 1 cubed is 1, then minus 6 times 1 squared, then plus 9 times 1. And what does this one give us? 1 minus 6, that is minus 5. Minus 5 plus 9, isn't that a positive 4? I think so. That is a positive 4. So meaning this coordinate is, this point is going to be 1, then 4. And then for x, which is equal to 3, then y will be 3 cubed, that is 27, minus 6 times 3 squared, then plus 9 times 3. Okay, now 3 squared is 9 times 6. What does this one is 27, then 9 times 6, that is 54, yes. 9 times 3, that is 27. Now 27 plus 27, that is 54 minus 54, that is a 0. So meaning we shall have 3 here with a 0. Question 23, simplify. So here we are looking at factorization. You factorize up here and also down. Okay, now here what is common is 2x. That means here we shall remain with x, then plus 5 here. Okay, down, this is a difference of 2 squares, x squared minus 5 squared. And we know that a squared minus b squared is the same as a plus b, then a minus b. Okay, if you get a plus b times a minus b, a times a, that is a squared, then a times minus b, you'll get minus ab, then b times a, you'll get ab, and then b times negative b, you get minus b squared. So do you see how these two disappear, and then you remain with a squared minus b squared? So that is why we say that a squared minus b squared gives us this. So we shall have 2x here into x plus 5, then out of this is x minus 5, then times x plus 5. So this one will cancel with this, and then our answer becomes 2x out of x minus 5. So this has been it for this paper. Thank you so much for watching. May God bless you. If you find the content very helpful to you, kindly like, share, and even subscribe. See you in the next videos.